Okay, this is our third chapter 16 video. We left off at On Your Own 16.5 last time, and hopefully maybe you've started to work review questions 1 through 5 and practice problems 1 through 7. And this video is going to be about how batteries work, specifically the simplest kind of battery, the galvanic cell. The galvanic cell was, so we're on page 3 on your notes, was developed by or named after Luigi Galvani, an Italian scientist. And for a galvanic cell, you have the anode, which is the negative side of the battery. All right, one way you can remember it's negative is it has the letter N in it. You have the cathode, which is the positive side of the battery. One way to remember that cathode is positive, it has a T in it that looks kind of like a plus sign. You have a salt bridge, which is a source of ions to keep the redox reaction going. And then you have electrodes, which are metal strips that provide electrical contact between the wire and the aqueous solution. So we're going to draw all this. Now there is a YouTube video on a galvanic cell that I'm going to link to on my Weebly website. You can watch it. It might help you. It's just a couple of minutes, and it might help you understand the galvanic cell a little better. So let's look at 16.6, which is on page 542. And we're supposed to draw, we're given a reaction, and that reaction is 2H2. And this time I need to put the phases. So aqueous plus solid manganese makes hydrogen gas plus Mn2+, which is aqueous. The first step is to figure out the oxidation numbers. For hydrogen plus, okay, it's the charge plus 1 over the number of atoms. And also this isn't H2, I'm sorry about that. So it's just H plus. Charge divided by the number of atoms. So that is plus 1. Manganese is all by itself, and the charge is 0, so that's going to be 0. Hydrogen has a charge of 0. 0 over 2 is 0. And then manganese would be positive 2 over 1, so plus 2. Hydrogen goes from plus 1 to 0. That means it's reduced. Leo says GER, reduced gain of electrons is reduction. If it gains electrons, that means it's the positive side of the battery. Electrons are negative, they want to get the positive. So it's the cathode. So manganese then is oxidized. It's the other one. And it's the anode. It lost electrons. Electrons are negative, they're running away from the negative side of the battery. So what we want to do is draw and label the parts of a galvanic cell. Okay, so you're going to draw 2 beakers. Right, that's my attempt at a 3D representation of beaker. Then we're going to draw 2 metal electrodes. So just a strip of metal. I would like you to always draw the anode on the right and the cathode on the left. So this is the cathode. It's positive. It's got the T, which looks kind of like a plus side. Anode. It's negative. It's got an N in it. It stands for negative. Now we're going to put a solution in this beaker. So I'm going to just kind of draw that. There'll be a lot of different types of solutions. We're going to connect the electrodes with wire. And we need an arrow. The electrons flow from negative to positive. So electron flow. Now, in order to keep this reaction from stopping, okay, then we need something called a salt bridge, okay, because if all the negatives go to the positive side, eventually this side will be negative and the reaction will stop. So it has to be, salt bridge is just a tube, and the end of the tube needs to go below the top of the solution. Salt bridge is just a source of ions. So it would put positive ions to this side to keep it replenished and negative ions to this side. Okay, so we got art in this chapter, right? Not too much. We need to too much left to label. So you need to label the reactants. Okay, you don't have to label the products, but you need to label the reactants. And since this is aqueous, we know that we have an H plus solution. But the manganese is solid, so we know that this electrode is made of manganese. We don't know what this electrode is made of. Any kind of metal. Probably zinc. But we don't know. It could be a lot of different kinds of metals. Alright, so we've got our salt bridge labeled, our electron flow, our electrodes, cathode, anode. That's it. Okay, so that is how you do this kind of homework problem. So in our case, 16.6. Now what I'm going to do for the next one, just to save time, alright, you can pause the video if you need to, but 16.7, I'm going to erase the reaction. I'm going to erase where we labeled the reactants. But everything else is good. So really, if you can just, you'll get half credit on a test just by getting this part right. The other half of it is the redox part, the redox reaction. So 16.7, let's write down the reaction. We have 3Cl2. That's aqueous. Plus 2Al, solid, makes 2Al3 plus plus 6Cl minus. We need to figure out the oxidation numbers. Alright, chlorine all by itself is going to be 0. Aluminum all by itself, 0. Charge over the number of atoms. The charge is 0. Aluminum plus, or 3 plus, would be plus 3. 3 over 1. And chlorine, again, we're not worried about the coefficient out front, just the charge. That's going to be minus 1. Negative 1 over 1. Charge over the number of atoms. So, we want to figure out the anode and the cathode. Well, chlorine goes from 0 to minus 1. It is reduced. The oxidation number is getting smaller, so it's reduced, which makes it the cathode, or the positive side. Alright, my writing there is almost as messy as Carson's. Goodness. That makes this side the oxidized, which is the anode. Gain of electrons is reduction, and loss of electrons is oxidation. Alright, so if you lose electrons, that makes it the negative side. And so you can go ahead and pause the video now if you want and redraw all this on your notes in the space in 16.7. Redraw all that. Alright, and now we're back to it. We just need to label what's down here. Okay, well, we have aqueous Cl2 solution. The electrode, it's aluminum solid, so we know that our electrode is made of aluminum. Alright, it's not always the first one is reduced and the second one's oxidized. It can be reversed, alright? You gotta go through the reaction and figure it out. Alright, but that is the galvanic cell, and that is a major part of your homework, okay, drawing these. And I don't think it's too bad. People usually do real well on this part, on the test. So let's go through just a little bit more. I don't think I can finish the chapter before this video cuts off. So if you need to pause the video, go ahead and do that to finish this up. Okay, in your book on page 543, it talks about a car battery, a lead acid battery, and you do need to know something about a car battery, and there's a YouTube video that I show that I will put a link to on my Weebly website that you can watch if you would like. But you need to know, alright, I'm not going to really go through it, but you need to write in this reaction, I'll go ahead and write it out. So we've got PbO2 plus lead, solid lead, plus battery acid, sulfuric acid, H2SO4. And that makes, and I'm not really worried about the products, but it's on your notes. Okay, but you do need to learn, okay, that in a car battery, the PbO2 is the cathode. Electrons are flowing to the lead oxide, solid lead oxide cells. Okay, and so it's the positive side. And you need to know that the lead is the anode. Okay, so you just need to know that for the test, and that is on page 543. Okay, page 543. Just make sure you read over that, look over that. And the electrolyte, this is like a salt bridge. It's a source of ions. Okay, the electrolyte is sulfuric acid, which a lot of people just call battery acid. That's why batteries are dangerous. Car batteries are dangerous. This acid is really strong. So it's a conducting solution, the electrolyte. So a lead acid battery, a car battery, is rechargeable. It's made of such a strength, you know, they're really heavy. They have a strong casing. They're such a strength that the reaction can be reversed. It generates a lot of heat, but the reaction can be reversed and recharge the battery so that you're not replacing your car battery all the time. So there are 6 plates in a car battery. So you need to know this, 6 plates, and each plate provides 2 volts. Okay, think of that as a volt is kind of like electrical pressure, all right? So that gives a total, a car battery is 12 volts. So you need to know that. Okay, that will be it for this video. And we're going to draw the parts of a dry cell battery on the next video, and that will complete chapter 16.